Hi, I'm Emilia. So to start the video, I will tell you guys about the history of the ionic bonding, where the idea of ionic bonding are gradually evolved through the ages. Around 1830s, Michael Faraday's experiment on electrolysis showed that certain substance would conduct an electric current when dissolved in water. He thought that the electricity caused the substance to break up into charged particles. He introduced the term ion and invented the terms cation and anion for the positive and negative particles. In 1884, August Arrhenius reasons that an ion is an atom carrying a positive or negative charge. He proposed that a compound like sodium chloride broke up into ion when it dissolved in water, whether or not an electric current was present. In 1897, J.J. Thomson showed that cathode rays were streams of free electrons. He felt that electrons were somehow involved in bonding and even proposed that the atoms in HCl are joined by a tube of electromagnetic force, and he suggests that HCl has a positive and negative end. By 1898, Wilhelm Wien had showed that the EM ratio of canal ray depends on the gas in the discharge tube. He showed that the positive charge, where unlike electrons, were not transferred from one atom to another and so could not be involved in the bonding. From that time on, theories of ionic bonding and the transfer of electrons developed rapidly.
Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to share to all of you about ionic bonding. Let's proceed to what is ionic bond. An ionic bond can be formed after two or more atoms lose or gain electrons to form an ion. Ionic bond occur between metal losing electron and non-metal gaining electron. Ion with an opposite charge will attract one another, creating an ionic bond. Ionic bonds are stronger than hydrogen bond but similar in strength to covalent bond. Let's proceed to how ionic bond formed by the complete transfer of some electrons from one atom to another. The atom losing one or more electrons become a cation, a positively charged ion. The atom gaining one or more electrons become an ion, a negatively charged ion. First, a salt such as sodium chloride is a good example of a molecule with ionic bonding. The atomic number of the element sodium is 11, meaning that sodium possesses 11 protons. Its electronic configuration is 1s2, 2s2, 2p6, and 3s1. The another atom of the salt is chlorine, which has the atomic number of 17, and the electronic configuration is 1s2, 2s2, 2p6, 3s1, and 3s2 and 3p5. Next, the formation of sodium chloride. The atomic number of sodium is 11. Electronic configuration is 1s2, 2s2, 2p6, 3s1. In this state, there is only one electron is in the valence shell. The tendency is for sodium to lose an electron, so that the how resulting valence shell of 2 is it in the more stable state full of charge. This loss of an electron results in the ionization of sodium to form the positively charged ion sodium. The atomic number of chlorine is 17. Its configuration shows that the chlorine becomes the negatively charged ion. Chlorine becomes of the propensity of sodium to lose one electron and of the chlorine to gain an electron to the element.
Now, I will continue this video by explaining the properties of the ionic compound. Firstly, they form crystal. Rather than amorphous solid, ionic compound form crystal lattice. Although molecular substance can form crystal, they generally do so in different shapes than ionic crystal, and molecular crystal are typically softer than ionic crystal. An ionic crystal is a regular structure at the atomic level where the cation and anion alternating and generating a three-dimensional structure based on the smaller ion evenly filling up the gap between the larger ion. Next, they have high melting point and also high boiling point. To overcome the interaction between the positive and negative ion in ionic compound, high temperature are required. As a result, melting or boiling ionic substance require a lot of energy. They also have higher enthalpies of fusion and vaporization than molecular compound. Ionic compound have enthalpies of fusion and vaporization that are 10 to 100 times greater than those of molecular compounds, just as they have high melting and boiling temperature. The heat required to make a single mole of a solid under constant pressure is known as the enthalpy of fusion. The heat required to evaporate 1 mole of liquid compound under constant pressure is known as the enthalpy of vaporization. Next, ionic compounds are hard and brittle. Ionic crystals are difficult to separate because positive and negative ions are strongly attracted to one another. When pressure is applied to an ionic crystal, however, ions of similar charge may be driven closer together. Ionic solids are fragile because electrostatic repulsion is strong enough to fracture the crystal. They also conduct electricity when they are dissolved in water. The dissociated ion in ionic compound dissolved in water are free to carry electric charge through the solution. Molten ionic substance, which is molten salt, are also electrically conductive. Finally, they are also good insulators, where ionic solids do not conduct electricity well compared in molten or in aqueous solution, since the ions are so closely bonded to each other.
Okay, next is the application of ionic bond. So there are many applications of ionic bond in our daily life. So the first one is the table salts. So basically, the chemical's name of the table salt is sodium chloride, NaCl. It has a cubic unit cell, and ACl forms easily through the combination of its component elements sodium and chlorine. So the equation is the 2Na plus Cl2 equal to 2NaCl. So the reaction is extremely exothermic, producing a bright yellow light and a great amount of heat energy. The attractions between the Na plus and Cl minus ions in the solid are so strong that only highly polar solvents like water dissolve NaCl well. Salt plays a crucial role in maintaining human health. It is the main source of sodium and chloride ions in the human diet. And sodium is essential for nerve and muscle function and is involved in the regulation of fluids in the body, whereas chloride ions serve as important electrolytes by regulating blood pH and pressure. So next is iodized salt. Iodized is one of the essential dietary minerals that is required in the human body for normal thyroid function, growth, and cognitive development. Worldwide, around 1.9 billion people suffer from iodine deficiency, and almost a quarter of which are school-age children. To overcome these challenges, governments around the globe launched several awareness campaigns promoting the use of iodized salt over plain salt. Iodized salts are a mixture of table salt with some salt of iodine, most commonly potassium iodide Ki. Since it can be added to a common food item without altering the taste, it is an easy way to get iodine in the diet. Potassium iodide is produced using elemental iodide and potassium hydroxide, or in more scientific term, which is in the equation Ki2 plus 6KOH, we can get 5Ki plus KiO3 plus 3H2O. The ions K plus and I minus combines via ionic bonding to form Ki and has a similar crystal structure as sodium chloride and ACl. So next is a fluoride toothpaste. So basically when people going to buy the toothpaste in the store, they will see several variants such as anti-cavity toothpaste, toothpaste with salts, whitening toothpaste, sensitivity toothpaste, and others. All of these variants have fluoride as the common ingredients. The use of fluoride toothpaste is important to prevent and reduce the severity of dental caries in all age groups. The efficiency of fluoride as a caries preventive agent depends largely on its concentration and availability in the oral fluids to effect the demineralization and remineralization balance. Fluorides are delivered through toothpaste and oral fluid as a salt named sodium fluoride (NaF). Sodium fluoride in toothpaste and mouthwash safely and effectively help to prevent tooth decay when formulated correctly and used as directed. It is an inorganic ionic compound dissolving in water to give Na plus and F minus ions and has a crystal structure similar to NaCl, where both Na plus and F minus occupy octagonal coordination sites. So next is baking soda. So basically baking soda is another most commonly found chemical in a household, specifically in the kitchen. It is one of the most vividly used leavening agents used in baking goods to improve their texture and appearance. In chemistry, it is known by the name sodium bicarbonate. IUPAC name will be the sodium hydrogen carbonate and exists in nature as a crystalline structure, nacolite, which is later ground to form a fine powder baking soda. It is an alkaline chemical compound with formula NaHCO3, sodium cation, Na plus and a bicarbonate and ion HCO2- are held together via ionic bonding to form this salt. Sodium bicarbonate is generally atmospheric in nature. However, the aqueous solutions are mildly alkaline due to the formation of carbonic acid and hydroxide ion. With the formula HCO3 minus plus H2O equal to H2CO3 plus OH minus. Moreover, one must not confuse baking soda with baking powder. While both the compounds may look similar, baking powder is a mixture of baking soda, cream of tartar, a dry acid, and sometimes cornstarch. Lastly is household bleach. So bleach is a name given to all compounds that are used for cleaning stains and removing color from fabric. It often refers specifically to a dilute solution of sodium hypochlorite, also called liquid bleach. Sodium hypochlorite NaOCl, also known as hypochlorous acid, is a salt comprising a sodium K ion Na plus and a hydrochloride anion OCl minus. Anhydrous sodium hypochlorite is unstable and decomposes explosively. Therefore, it is hydrated with 5 molecules of water of crystallization to form NaOCl5H2O, which is a non-explosive pale greenish yellow solid. At room temperature, sodium hypochlorite is more stable in dilute solution that contains solvate Na plus and OCl minus ions. If sodium hypochlorite is not properly stored in airtight container, it may react with carbon dioxide to form sodium carbonate, which is 2NOCl plus CO2 plus H2O will give Na2CO3 plus 2HOCl.